Okay, good afternoon, everybody. Can you guys hear me in the back? Ellen? Okay. So Beth Schmoyer was supposed to be here with me to present. Unfortunately, she had to stay back in Seattle and get some work done. So you're stuck with me. I'll do my best. If there's hard questions, Ellen Stewart is in the back. She will be answering them. So I'm assuming everybody knows where Seattle is, but for a little context, Seattle Public Utilities, we run 3 lines of business. We're actually 20 years old this year. We were formed back in 1997. We supply drinking water to the city of Seattle and many of the communities around Seattle. We are the solid waste hauler. We contract that work out and pick up residential and commercial garbage. And then we're a drainage and wastewater utility. That we operate the stormwater system, or MS4. We have a combined sewer system that we operate and permitted under, and then we have sanitary sewers. We do not operate a wastewater treatment facility. We're a wholesale customer of King County, and they operate West Point, which is where most of the sewage from Seattle goes. So our source control program, we're pretty proud of it. I think most people know of Seattle because of our GSI program, but our source control program is actually better. We have a great team. I actually don't do any of this work. I just give them advice, help them get unstuck, get them grants, manage grants. These are the actual people who do the work. They do a great job, great group of people, excellent program. New person we have is Eric Lust. We just got him up from California, great addition to the team. He's wandering around. If you get to meet him, good guy. So the source control team has been at this work for a long time. They started this work prior to it being permit requirements. And these statistics are focused on the Lower Duwamish Waterway, which is really where the bulk of the work is focused. These programs are applied citywide in the MS4 and soon to be applied in the combined basins as well. So these statistics are for our Duwamish work. A lot of source tracing samples collected of solids from our MS4, and that is the basis of our program. It's how we prioritize work, it's how we track effectiveness, it's how we know where we should be applying our programs and if we're making improvements. Done a ton of business inspections. I think we've visited every business in the Duwamish at least once. We use corrective action as a tool. We issue a lot of correction actions with fines. We have a progressive enforcement process, a penalty matrix where depending on the nature of your violation and how many times we visited you, your fine goes up. We also refer problem cases to either EPA criminal or to Ecology to help us with enforcement. We clean our drainage lines to remove historical sediments that have accumulated that may contain pollutants that could discharge in the river. And it also provides us with a clean slate for source tracing so that we can put our samplers in and we can determine if pollutants are still entering the system from historic sites or maybe new sites. And then our illicit discharge and detection program, we've screened the entire basin to find where we have cross connections or things of that nature. So a little bit about the area. Again, no map of Seattle because I think everybody knows it. But so this is the Duwamish Waterway. Starts up at Mount Rainier, which would be way back here, at Lake Washington, Elliott Bay, and then Puget Sound is over on this side. These are the basins, the MS4 basins that discharge into the Lower Duwamish. In addition to the MS4 basins, there are combined sewer overflow basins owned and operated by Seattle. King County International Airport has stormwater basins, and then King County also has CSO basins. Boeing also has property, so there's a mix of different owners of the outfalls. We use some of those outfalls to discharge our stormwater into the river. The size of the basins vary greatly. This always surprises people, but back in the day, they wanted to protect Lake Washington, so they built deep pipes to get the water from this area, which should normally drain into Lake Washington, into the Duwamish. And that's a challenge as it's our largest basin. You can drive a truck up the outfall for that basin. It's very large. So why are we doing this work? Well, the sediments in the Duwamish are contaminated due to historical activities. So we're in the process of a cleanup under Superfund. The record of decision was issued in 2015 with outlines, the actions that are going to be taken to clean up the river. It's going to take a long time. I think 17 years might be optimistic at this point since we haven't actually started yet. A lot of dredging, capping, natural recovery, which is where we just allow the sediments from upstream to cover up the contaminated areas. But the main goal for our program in working with Ecology is source control to prevent recontamination so that we're not back here in 20 years cleaning it up again. It's going to be very expensive. We're in a process figuring out who's going to pay, but fun times. So I'm going to give you a little background on the stormwater permit. I would assume a lot of people kind of know this, but it's important for this presentation. So in Washington, we're a little bit unique. California is somewhat similar in that not only do we have to comply with the national NPDES rules, that you have a programmatic approach to control pollutants, and if you have that programmatic approach in place and you're doing it, you're in compliance. But in Washington State, we also have the State Water Pollution Control Act, which says that at the end of our MS4, we have to comply with water quality standards. So we have two parts we have to do. It's kind of hard to comply with water quality standards at the end of your pipe all the time, even though you're implementing a program. So kind of trying to fix that and trying to create a pathway for compliance for municipalities. Ecology created S4F, and it's to reconcile the irreconcilable, which is that you have a program, but you're still violating water quality standards. So how do you come in compliance? So there's a pathway for S4F. So the way that S4F works is you're out doing your program, maybe you're sampling near the end of the pipe with doing stormwater sampling or solid sampling. In our case, it would be solids. We take a measurement out of the pipe, we analyze it at a lab, we have it validated, and we determine that there are pollutants in that sample that are in excess of a standard or some benchmark that we're using to screen the data. We also know that offshore of the outfall in the receiving water body, there are contaminated sediments. So therefore, we can put the two together and come to the conclusion that our system has a probability of causing or contributing to that violation in the receiving water body. So we're polluting, we're breaking the law, we need to let Ecology know. We write a letter to Ecology within 30 days of becoming aware. Ecology writes us back and says, the plan you have is going to be sufficient, or nah, it's not enough. I think we need to do some things differently. You need to come up with an adaptive management plan. And that's the situation that Seattle Public Utilities is that we notified for the Duwamish on 5 outfalls for PCBs and phthalates. We worked with Ecology. We had a pretty collaborative back and forth on what should this adaptive management contain, how does it fit into the sufficiency that Ecology is doing for the Superfund cleanup, how can it mesh in with the existing permit, how does the MOCA team get involved. And in essence, we came up with the source control implementation plan, and Ecology developed Appendix 13, which is in the Phase 1 permit, that outlines the actions that Seattle has to take above and beyond the permit requirements. In addition, Ecology decided that it was in everyone's best interest to expand the notification to all of the outfalls we discharge out of for all of the contaminants of concern in the Lower Duwamish, which are metals, PCBs, semi-volatile organic compounds such as phthalates, hydrocarbons. I think that's it. And those, fortunately, were the parameters that we were looking for in our source trace sampling data, so worked out for us. So our source control implementation plan, which I'm going to talk about for the rest of this presentation, meets the adaptive management requirement in the permit. It meets the Appendix 13 requirements to have this plan. It kind of lays out what we're currently doing and describes the work that we're using to enhance the program, to grow the program, to develop new tools and new techniques for identifying sources of pollution, and lays out our pathway for the next 5 years. So I mentioned a little bit earlier that we have a data-driven approach. So this flowchart roughly explains the work and how the source trace sampling data, business inspections, and line cleaning are kind of feeding off of one another because we're collecting some of our source trace sampling during business inspections and line cleaning, but then this data is also helping to prioritize where we conduct some of this work. So we prioritize, we outline the actions. We also do a lot of coordination with other departments, and we get requests for our data and share the data and talk about where these pollutants may be coming from, what we could do together to address them. It also guides some capital improvement projects. I don't know if anybody went and heard Sheila's talk. Sheila's in the back next door on South Park, but that helped us decide that that's a good capital improvement project that we should do. It helps guide some of our O&M activities like catch basin inspection and maintenance. And then we also use it to help SDOT with their street sweeping program and other paving programs. The nice thing about the source tracing data is that it also can serve as our effectiveness monitoring data. Adaptive management in the permit and S4F requires that you do effectiveness monitoring. So we have sediment traps near the end of the pipes where we're collecting solids, with the hope that by analyzing the data, it can help us understand if our actions are effective or if we need to change them or what we should do next. So this is a lot of stuff, but I'm just using it as an example of how we prioritize. So we'll look at diagonal, and so these are all the samples we've collected, how big it is. I have 227 samples. Diagonal is that big purple basin that I explained earlier. This is kind of our data, and this is in-waterway data. So here we see that we have samples from our system that are above our screening level, and then there are samples in the waterway that are above the standards. So we have a linkage, so we're going to prioritize that basin for actions. And then this is all the outfalls that we either own or we're discharging out of, and if we have samples and all the information about it. So then the next table is just the same outfalls, and it kind of lists the actions that we're going to be doing programmatically, and this is all of our information in the source control implementation plan. So it lays out to ecology, the public, interested people, kind of what our plan is for the next 5 years for source control in the Lower Duwamish Waterway. So now we'll get into some of the actual programs that we're doing. So source tracing, I've been talking a lot about this. These are sediment traps in our MS4. And so we've been using sediment traps for a long time because they give us a direct representation of what we'll be discharging out of the pipe and potentially contaminating the sediments in the water body. They're also cost effective because we can put them in place and we just leave them. There's not batteries or solar panels or pumps or anything that would break or malfunction. So they're an effective way to collect a lot of samples with not a lot of effort. It's effort for the people to go down in the pipe and install them, but once you set them, you go back and visit them periodically and collect the samples. We also find that we generally detect pollutants in the solids where when we've done whole water sampling, we sometimes don't detect what we're looking for. There are some drawbacks with sediment traps, however, as you can see if I can go back. They're kind of high. They have an Nalgene bottle. They stick up. So you can't use them in small diameter pipes. And this has been a complaint from people. And then there was also concern that maybe that sampling design isn't actually catching all the solids that are going down the system. It might be missing some of the fines or things of that nature. And so we got a grant from Ecology, and we worked with Cardno to come up with a better sediment trap for small pipes. And so it started out, this is an onion container from the Container Store in the U Village. We just drilled a hole in top of it as our prototype. And we got this idea from a ocean sampling concept that was done out at Woods Hole in the 70s. We were kind of trying to find any and all type of samplers that we could investigate, and we came up with this and tried it. We were fortunate enough that because of our CSO program, we have a flume where they test flow meters and things of that nature. So we were able to utilize the flume and make synthetic stormwater where we understood what the particle size distribution was in the synthetic stormwater, run it with the prototype traps in it, and then analyze those. And we found that these dome samplers, this one, actually the particle size distribution in the trap matched what we had put in the synthetic stormwater. I mean, really pretty close. So it gave us great confidence that this design was going to work. So we had a couple fabricated out of stainless steel. We have them out in the field right now testing them. If you want to know more about this, James Packman, I don't think he's here, but he's giving a there he is. He's giving a presentation at StormCon, right? Yeah, so he'll be talking more about this. Field traps are out. We've collected one round of solids out of them for analyzing particle size distribution. We don't have the results back yet, but the traps are still out there sampling because the next round is for chemical. In addition to these two traps, we also have what's known as a Hamlin trap, which is something that's used in eastern Washington. It's a looks like a sluice box sort of trap, but we scaled it down to fit in small pipes. And then the City of Portland came up with a trap as well that's called the SIFT, and we're trying that as well. So we'll have a paper out on the results of that probably towards the end of next year. So everybody's favorite, the detection dog. Beth Schmoyer and others had this great idea. If dogs can smell drugs and bombs and whatever else, they can probably smell PCBs. PCBs have a chlorine type smell. We actually have a staff member who can smell them. And so he's the one actually doing the work. It was Beth's idea, but he's project management. So we've using a grant from Ecology, we're working with University of Washington Conservation Canines to see if we can get the dog trained up so it can detect PCBs. Because by using the solid method, we can trace it up so far, and then you have this big area. Say PCBs are in this room. Well, it's very expensive and time-consuming to find them. But if we had a dog and we could run the dog around, the dog can find them pretty quick, and then we can figure out what to do next. So this is Samson. I have a video at the end that I'll show. It's kind of fun. This is Samson training, where we spiked different samples with PCBs, and he's training to see if he can detect them. And when he detects them, he sits down and he gets his ball. And for dogs like this, you want dogs that are play motivated, not food motivated. So Samson is very play motivated. He also finds goshawk poop. That's his job. He's out in eastern Washington right now doing that. So business inspections. You know, core work of Ellen's team is doing business inspections. It's required as part of the Phase 1 municipal stormwater permit. They've been doing it for a long time, so we've spent the last couple of years doing process improvement. We used the capacity grant that we got from Ecology to hire a lean specialist, lean or Six Sigma or Kaizen. And we sat down with that individual and we put butcher paper on the wall and spent 5 days mapping out every step of our business inspection program and our stormwater facility inspection program. There were two purposes for that. The first was to identify where there's waste, not that anybody's doing anything wrong, but just where we have redundant processes, or things of that nature, to try to streamline our business inspection program and our stormwater facility inspection program, because we keep getting more work, but we don't get more people. So we have to figure out how to still comply with the same number of people. The second part was we are using a database in Access that's from, I don't know, 1990 or something like that. It's super old. It's crashing all the time. The crews are still filling out paper forms and then coming back in the office and typing that in. And we said, you know, we can do this better. So we're designing a new database in MS Dynamics that's going to have a mobile component. And those flow charts that we made in the lean process are absolutely vital to map out how the database is going to be constructed. And then the second part of that is that they're really great for new employees to map out how you should do your work. The other thing we're going to do around business inspections is we're hoping to partner with Tacoma and take advantage of some RSMP money and do an effectiveness survey of businesses who've received business inspections, excuse me, to try to figure out how long they retain knowledge about proper implementation of BMPs, so that that data can help inform how frequently you should go back to businesses. And the hope is by partnering with Tacoma, we can get a bigger data set, and then this information will be useful to Phase 2s and others, but it'll be very useful to us as well. So line cleaning. One of the things we've done a lot of in the Lower Duwamish is line cleaning to remove those existing sediments and contamination, and then it makes that clean slate for source tracing. So in Appendix 13, we are signed up to do 4,000 linear feet of line cleaning every year. We usually do a little bit more. This work has been funded historically by Ecology, but we're not eligible for those grants right now. We're hoping that changes, so we're taking it on ourselves. And it's really focused on where we have data. So this map, it's kind of hard to see, but these little blobs are where we have PCB data, and then the line cleaning is occurring where the blue is. So it's focused on areas where we have data and we know we have problems, but it's also kind of an opportunistic thing where we might have a piece of property or a location where we can set up the decant facilities and the bin to store all the muck that comes out of the pipe. So that's something we're going to continue to do. We find that it's a very effective way to remove those historical pollutants start with a clean slate. So O&M optimization. One of the things in Appendix 13 is for us to try to use data that we have around catch basin inspection and maintenance and the data from source tracing to try to figure out how we could inspect and maintain our infrastructure in the Lower Duwamish a little bit better. As part of our combined sewer overflow program, we use CMOM, which is capacity management, operation, and maintenance, to prioritize and strategize where we're going to clean lines and do maintenance and things of that nature. And since we have experience with that, we wanted to see if we could apply those principles to the stormwater system. So we're going through a process right now of evaluating our data, applying those principles, and trying to figure out if there's a way to inspect and maintain catch basins a little bit better. And that report will be out next year as well. We're not alone in this. We do a lot of work with the Department of Transportation in Seattle. This is what the roads down in Duwamish actually really look like. There's gravel. There's actually pavement underneath here, but it's just gravel, no gutter, no infrastructure at all. The river is actually right there. That's Boeing on the other side. So what we do is we partner with them and go in and they pave and create sidewalks. This one actually has a bike trail. And then Seattle Public Utilities puts in the stormwater infrastructure and then treatment. So it's a way to improve it, control this source of pollution. We also work with the model toxics group that if there were contamination or something to try to get that cleaned up. So we have a big plan over the next 5 or so years to do a lot of paving and drainage improvement down in the Lower Duwamish as well. We also work with SDOT on street sweeping. I think people are familiar. We have our street sweeping for water quality program where we sweep arterials within our stormwater basins to pick up pollutants so that they're not entering into our storm drain system. So we're continuing that work. We actually expanded it under a different program called the Integrated Plan, but we're factoring that into this plan. And SDOT is doing a number of studies about where they should do repaving and how freight is moving around the Duwamish. As an industrial area, the Duwamish is actually growing. The Office of Economic Development is encouraging businesses to come in and develop in that area. So SDOT's trying to figure out how to make roads more accessible to freight, move around. And then another thing is street use permits. If you want to do anything in the right-of-way, you need to get a permit from SDOT. So they've had BMPs in their street use permits for years that require people to control pollutants, and we're working with them to improve that process so it gets applied more frequently. So South Park, Sheila just talked about this a half hour ago, but we're looking at installing a large stormwater treatment facility in the South Park neighborhood. We're installing a stormwater pump because we have flooding in that basin, and that stormwater pump gives us the opportunity to treat stormwater as well. And we're looking at, I didn't go to Sheila's talk, but I don't know what we're looking at anymore, but it's either chitosan enhanced stormwater or electrocoagulation. This is not the site. This is what one of those units look like. So we're working on it right now. It needs to be installed by 2025. It's going to treat stormwater from that basin before it discharges into the Lower Duwamish Waterway. So the other big part of this is coordination. We're not doing this alone. We're coordinating with the other departments within the City of Seattle, such as Seattle City Light, SDOT, Parks, to make sure that we're all meeting the permit requirements and we're controlling sources to the extent possible that we can. The inspectors participate with the Duwamish Inspectors Group, where they share information about source control, talk about issue sites, work out things. There's also the Lower Duwamish Source Control Group, which is similar, but involves more agencies. We interact with the Superfund people, through the CERCLA people, through the Lower Duwamish Work Group. We have a section in Seattle Public Utilities that's focused on the in-waterway cleanup part, and the work that we do is more focused on the source control work upland, so we coordinate with them. And then we also coordinate with Ecology Model Toxic Group to identify sites and try to fold in the work that they like to see done and the cleanup work that they want to do as part of our source control program as well. So one of the biggest, you've heard this all day, we're the source of pollution. There's a lot of problems. This is our approach to source control because it's a way to get the pollutants out of the stormwater, hopefully, before we have to treat them at the end of the pipe. And we really feel like our program is effective. It's going to help us prevent recontamination. It helps us comply with the permit, and the Lower Duwamish Waterway is getting cleaner. So like I said, I'm going to show you the dog video because that's pretty fun. All right, so hopefully it'll work. Okay, so what we're doing here is we're in our joint training facility. Those boxes have samples. Each of the circles is a sample. A couple of them are spiked with PCBs. The rest are just sand. And so Samson's out of the room. They're going to bring him in, and he's going to sniff around and try to find it. And when he finds it, he sits down, and he gets to play with his ball. And that's Beth in the light blue shirt, right there walking, who should have been here. And Mike Jeffers is the one on this side in the blue sweatshirt that just disappeared. All right, there's Samson and Julianne. There's no sound, but there's a lot of barking, actually. There, he found it. Okay, now they're just moving it around, and they did this for a couple days. They've done a lot of testings, and so did a lot of training with Samson to make sure that the handler and the dog were, fully getting this. And then they've actually gone out where we knew we had PCBs in the field and done some actual field trials. And it's all been very successful. Paper is forthcoming. So here Beth is hiding some paint chips that we know have PCBs in it out at the joint training facility to try to simulate something out in the real world. It's sped up, so it's kind of, it took a while, but so it's kind of fast. It's a little bit funny, but. Okay, so this will be a test. So it takes both the handler and the dog to figure this out. So see if you can see when Samson actually signals, because the handler didn't pick up on this one right away. Remember, he sits because he wants his ball. So. I heard someone say it. You're right. He found it. She didn't recognize the signal because he couldn't get down. All right, that's all I got.